a drug called chloroquine, and some people would add to it hydroxychloroquine. It is known as a malaria drug, and it's been around for a long time, and it's very powerful. And it's shown very encouraging, very, very encouraging early results.
This map's been floating around the internet, which looks at countries where there's a high death proportion from malaria, the one in blue, and a high death proportion of people that are dying from COVID-19 in yellow. Notice the two are very much complementary. Where there's a lot of blue, there's not a lot of yellow, and vice versa. Now, one of the drugs for malaria is hydroxychloroquine, which President Trump has been touting as potentially a drug that's going to help people with COVID-19. So the thinking goes, countries with malaria have either people on hydroxychloroquine or people that are taking hydroxychloroquine, and thus they either build up immunity or resistance to COVID-19, and thus there's very few confirmed cases of COVID-19. Like, that's the line of thought. There's also been an article in the New York Times which said that a group of moderately ill people were given hydroxychloroquine, which appeared to ease their symptoms. And talks about the fact that it's a malaria drug, was given to people that are mildly ill, and this was done in China. Cough, fever, and pneumonia went away faster, and disease seemed to less likely to turn severe in people who received hydroxychloroquine compared to the group that was not given the drug. The study was small and limited to patients who were mildly or moderately ill. Like many reports from the coronavirus, it was posted on an online server before review and peer review. A lot of scientists have been cautious about this, so there's been experiments done, or basically there's some doctors who have been prescribing it, and there's been anecdotal evidence that this actually helps with recovery. Now, this was done, there's some doctors in France who have been doing it. President Trump has advocated doctors just to try it because, for the most part, it's shown to not be that harmful. So his thinking is, well, if it's not going to hurt people, and it could potentially help them, then there's more upside than downside.
But we'll use it on people that are not doing great, or even at the beginning of not feeling well.
Sort of fall under the.
And John, what do we have to lose?
So this
Wait, John, it's been out there for so long. We hear good things. Let's see. Maybe it works or maybe it doesn't.
Let's talk about confounding variables. Let's explain these two maps in a way that does not involve hydroxychloroquine. For example, countries with malaria tend to have warmer temperatures. So maybe warm temperatures prevent the spread or mitigate the spread of the coronavirus. We don't know, but that could certainly be a confounding or lurking variable there. Countries with malaria tend to be countries with reasonably high poverty, which means that there's not going to be a lot of testing, which means that, again, there's very few confirmed cases. The map in yellow, it just talks about like confirmed cases from death. And there's been quite a bit of evidence that shows that in some of the poorer countries, people potentially might be dying from COVID-19, but their death is attributed to something else, like basic pneumonia or whatever. Countries with malaria tend to have people that are a lot younger in general. So sub-Saharan Africa, the median age in those countries is 19. And we already know that younger people are disproportionately less affected by COVID-19. So you could just potentially explain this simply by age demographics.
But the information that you're referring to specifically is anecdotal. It was not done in a controlled clinical trial, so you really can't make any definitive statement about it.
Now, let's look at the actual study that came out of China. This was an experiment. So in the new study, 62 patients with an average age of 45 did have a control group, so that's good. It was conducted in the hospital in Wuhan University in China. Wuhan is the epicenter of this whole outbreak. The patients were carefully chosen to exclude people with medical problems that could be made worse by hydroxychloroquine, like abnormal heart rhythms, certain eye diseases, or liver and kidney problems. Half the subjects, the controls, received the usual care given to the coronavirus patients, and half had usual care plus hydroxychloroquine. The usual care included oxygen, antiviral drugs, antibiotics, and other treatments. Their disease was considered mild, that's important, even though all had pneumonia that showed up on CT scans. After given informed consent, they were assigned to random, so random assignment, that's key in experiments, to either the hydroxychloroquine or the control group. They were treated for 5 days, and their fevers and coughing were monitored. So fevers and coughing, those are the response variables. They also had chest CT scans for days before the study treatment began and the day after it ended. Coughing and fever eased a day or so earlier in the patients who received hydroxychloroquine, and pneumonia improved in 25 of 31 as opposed to 17 of 31 in the controls. Now, if we wanted to actually see if that difference is statistically significant, we would do hypothesis testing, which we're not going to do in this video. The illness turned severe in 4 patients, all in the control group. So the illness turned severe in only the people that were in the group that did not have hydroxychloroquine. So that's another good, potentially sign for that. Dr. Schaffner cautioned that the results applied only to patients with relatively mild illnesses, like the ones in the study, and could not be generalized to advanced cases. So again, we're looking at where our sample is drawn from, and our sample is drawn from patients with mild symptoms and could not be generalized to the whole population of people that are admitted for COVID-19. Let's look at that from the framework of a completely randomized design. You've got the subjects, experimental units in this case, and you've got one treatment, you've got another treatment that's randomly assigned, and then you compare the response variables. In this case, our subjects are the 62 patients with relatively mild symptoms. Treatment 1 is the usual care. Treatment 2 is usual care plus hydroxychloroquine. And the response variables are coughing and fever levels. If I wanted to do a randomized block design, one of the ways that I might do it is I would start out with 300 subjects, for example. 200 of them would have mild symptoms and 100 of them would have severe symptoms. I would randomly assign the usual treatments and usual treatment plus hydroxychloroquine within both groups. I would compare the results within both groups, and then I would compare the results in general. And the reason I would block here is the severity of the symptoms could potentially impact the treatment. So I don't want to compound that. That would give me a better sense of how this drug potentially works.
Effective against SARS.
It was as I understand that, is that a correct statement? It was fairly effective on SARS.
John, you've got to be careful when you say fairly effective. It was never done in a clinical trial. They compared it to anything. It was given to individuals and felt that maybe it worked. So
was there anything to compare it to?
well, that's the point. Whenever you do a clinical trial, you do standard of care versus standard of care plus the agent you're evaluating. That's the reason why we showed back in Ebola why particular interventions worked.
What about blinding? What would blinding be in this situation? Here's my basic experiments. Now from Wikipedia, we could see that blinding is, in a blind or blinded experiment, information which may influence the participants of the experiment is withheld until after the experiment is complete. That would be a single blind experiment. Good blinding can reduce or eliminate experimental biases that arise from participants' expectations. So for example, if the patients were told that they're given this experimental drug, then they might, that could potentially influence what happens with, that could influence the response. So they could convince themselves that this experimental drug is going to make them feel better, and then they might actually end up feeling better. So a good experiment, if we're going to have single blinding, would then half the people would be given hydroxychloroquine and the other would be given a placebo, like a sugar pill, but told that they're also given an experimental drug. Or you just don't tell them that you're getting this experimental drug, and that would be unethical. But in China, they might do that. I'm not sure. The study didn't discuss blinding. What about double blinding? In a double blind situation, the researchers also don't know who's been given what treatment. Now, how might that play in here? The fever levels, that seems pretty straightforward. You just measure the temperatures and you compare them. But for coughing, if there's like ways to measure coughing that are more subjective, then you would want to double blind it. But I didn't get a sense from this experiment that double blinding was necessary. Coughing, it seems like that's a way to, I guess there's no downside to double blinding it. But from what I read, this experiment did not talk about either single blinding or double blinding. Single blinding would make sense. Double blinding would make it better. So I don't see a downside to doing either for this specific experiment.